Hi, and welcome to my first video discussion, I guess I could say. This one will be about phone chargers. Why phone chargers? Well, they've fascinated me for several years now, and over the years they've evolved and changed, and right now we're seeing a lot faster chargers than we were a few years ago. And I think it'd be nice to highlight those and see what the differences are, and well, basically tell you which charger to get for which device, because there's a difference. Um, yeah, let's start, shall we? I guess we should start in the past. Uh, yeah. So the past. Well, I guess it all started in I think before 2008. Before 2008, you basically had Nokia phones or a different brand, and it all had a proprietary charger. And each phone had its own charger at its own voltage. We weren't using lithium ion yet in everything, and it was was a giant mess. Basically, you needed to have the charger for your phone, or you couldn't charge your phone. So in 2008, HTC released the HTC Dream, which was the first Android device in the world. It was also called the T-Mobile G1. And it was a 500 megahertz single core touchscreen, bad screen, slow processor Android phone, but it was the first Android phone. And it had a mini USB connector to charge it. So that's when phones started using USB. It wasn't all well and set. Every brand would do their own thing and use mini USB or some other type of connector and some other type of cable or a barrel plug. Just a mess. After a while, people started realizing that getting a new charger for every phone was basically creating a lot of waste, or that's the reason they said. And they standardized micro USB as the charging plug which every phone needed to have. So that improved the situation a lot. We now had a standard plug, and each phone could use each other phone's charger, and they would charge, and it was all the same 5 volt, 500 milliamp amp charge. So yeah, that was pretty good. But phones became more powerful, so they needed a better battery. And with better batteries, the amps of the batteries rising. I believe the HTC had 1100 milliamps. We soon went to 1500, 1800, 2100, 25. And current day flagships often get released with 3000 milliamps or more. Sorry, milliamp hours. Charging 3000 milliamp hours with a 500 milliamp charger, well, that's going to take you at least 6 to maybe 8 hours or more. That's not really viable for a modern phone nowadays. So we needed faster charging solutions. USB was providing for it and wasn't in the specifications, kind of vague. Basically, USB 1 is 500 milliamps, that's 2.5 watts, 5 volts, 500 milliamps. USB 2 is actually providing the same kind of power. USB 3 stepped that up to about 900 milliamps, but generally we just say USB 3 is 1 amp. That gives you about 5 watts of power. And recently USB 3.1 has been released, and that's changed the game a whole lot. More about that later. So we needed more power. So all the vendors started to do different tricks to boost USB charging speed. For instance, Samsung would make special chargers or special cables, or you could actually cable moth them yourself. And you could short the data pins. USB consists of 4 pins plus, which delivers your voltage, ground, and 2 data lines. And if you would short the data lines on the charger side, on the device side of your cable, it would detect that it was a Samsung charger, and it would actually start to draw more power from the phone, or the phone would start to draw more power. You have to remember, any charging related stuff is managed in the phone. The phone determines, well, not so much which voltage it draws, because it's always 5 volt until recently, but it will determine how much amperage is delivered. So if it's either drawing half an amp, 1 amp, 1.5, 2 amps, or even more, it's all regulated in the phone. You can't force amps into a phone. The charge controller in the phone has to request it or use it. Okay. So we had HTC doing their own little secret protocol trick, and we had Samsung shorting their data cables to deliver 1 to 1.5 amps of charge. And I'm not an iPhone guy, so I don't know much about them. But they had their own little way of doing it. Of course, they had the large connector first, and now they have the Lightning connector. And basically, it's a closed ecosystem, so they don't tell anyone how they do it or what they do. Of course, clever manufacturers have figured out how to basically emulate what the Apple charger is doing in their own chargers and still deliver the higher power flow. Okay, so at this point, everything's still pretty much a big mess. Everyone, again, has their own standard. They have the same plug, but if you would use an HTC charger on a Samsung, it would charge at 500 milliamps and you'd be stuck for 5-6 hours charging your phone. Then if you take the included or brand charger, it would only take 2 hours. So, big difference. Okay, welcome by part 4. Wait, I'm not supposed to say that. Oh well. So, so now we can charge our phones at about 2 amps. So 2 amps gives you about 10 watts of power and 2000 milliamps per hour. So if you have a 3000 milliamp hour battery, it'd probably take about 3 to 4 hours to fully charge your phone. But a new problem started to occur. The more amperage you push through a wire, the more important the gauge of the wire becomes. So we used to have little Nokia cables like this, and those were fine in the 500 milliamps or even 1 amp days. But when we started to push more power, and especially also when Chinese manufacturers started to produce cables which looked the same on the outside but had less copper on the inside, charging speeds could still be a problem. Again, these proprietary standards are still there. So the first thing that started to happen is Qualcomm started to gain ground with their SoCs, and they were basically the SoC which were being used in most flagship and lower end phones at some point too. But Qualcomm was becoming a sizable party, and they introduced something called Quick Charge 1.0. You've probably never heard of it. You've probably never used it either, because Quick Charge 1.0 was supported on the Snapdragon 600. And, well, I personally don't know any phone which actually made use of it, because to enable quick charge, you need a quick charge charger, a quick charge cable, although a normal cable should work, and you need special circuitry and certain board stuff in the phone itself, which your manufacturer of the phone has to enable to make it work. Basically, you have to pay Qualcomm for a license to use Quick Charge, and no one did. So, okay, moving on a little bit. As I said, Quick Charge 1 was basically still 5 volts, 2 amps, but it's a closed ecosystem. So you would have the correct charger, cable, and phone, and that will work well together, even from different brands. Except no one did it. So Quick Charge 2.0 was introduced, and this was around the time of the Galaxy S5, the Sony Z2, LG G3, I think. So about 1.5, 2 years ago. that started to gain more traction. More companies used quick charge. It was enabled on the Snapdragon 800, 801, 805, 808, that lineage, and also the 400 line, which corresponds with that. I'll have a link down below in the description with a nice article on quick charge and what was introduced and how it works, etc. But quick charge 2 was still a bit wonky. I myself had a Sony Z2, which had a Snapdragon 801, but did not support quick charge. But the Samsung Galaxy S5, I think, yeah, and an LG did support quick charge. So, still confusing. Quick Charge 2.0 did enable much faster charging. Next to 5 volt 2 amps, it gained 9 volt 2 amps, 12 volts 1.67 amps, and even some kind of 20 volt mode, but I don't think that was ever used. So forward to 2016, we now have the Galaxy S7, we have the LG G4, HTC X, it's not the HTC M10. A good mention, the M8 and the M9 from HTC, the HTC One, both supported Quick Charge 2.0. Good. So now we have the Galaxy S7, HTC X, LG G4, those kinds of phones, and those all use a Qualcomm processor with Quick Charge 3.0 enabled. 3.0 basically has the same modes as 2.0 does, but they introduced an intelligent protocol which can communicate with the charger, and basically the phone can request voltage and amperage of anything at once between 3.2 and 20 volts in 200 milliamp increments. So now the phone can judge by the state of its battery, how warm it is, how full it is, etc., what it wants in voltage and amperage. And basically, looking back to without Quick Charge or Quick Charge 3.0 can give you about a 4 times increase in charging speed. Maximum charging speed in watts is 18 watt for Quick Charge 2 and 3. 3 is just more efficient because of the voltage curve it can enable if your charger device, cable, etc. supports it. So, yeah, that's all well and great, but it's still a custom standard, a proprietary standard by a manufacturer of an SoC, which the phone manufacturer has to pay a license for, which you have to get a special charger for, etc., etc. But at least it's gaining traction, and your quick charger for your LG or HTC will work on my Galaxy S7. Well, actually, the Galaxy S7 is a bit of a special case because there's 2 versions of a Galaxy S7. One using the Qualcomm Snapdragon 820, which would have Quick Charge 3.0, and one using the Exynos processor of Samsung themselves. And because of this, Samsung basically took a license for their Exynos processor for Quick Charge 2.0 and enabled Quick Charge 2.0 on their Snapdragon version, and doesn't use 3.0 because of compatibility issues between chargers otherwise. Great. So you can actually license Qualcomm technology, but of course it makes the phone more expensive, so not everyone will do that. And hopefully there's a fix for that in the future, but I will talk about that in a bit. So let's talk a bit more about Quick Charge. Basically, to enable Quick Charge, you need an adapter which will say a different voltage on it. Let me try and focus this. So this is my adapter which came with the Galaxy S7. I have an Exynos version, but it shouldn't matter. So here you can see it actually has 9 volts next to 5 volts. And here I have a Tron Smart charger, And this Transmart charger actually lists which voltages it can supply. It's Quick Charge 2 certified. And here you can see it can deliver the 5, 9, 12 volt for charging and which amperages. Okay. So next to raising voltage because of cable cable inefficiencies, I guess. If you don't have enough copper in your cable, carrying more and more amperage will become harder and harder and become less and less efficient. Nowadays you get these cables, for instance, which are a lot thicker than this one. Or even, this is a million well cable, they're more premium product, but those are even thicker. Of course, the thickness of the outside of the cable doesn't necessarily matter, but if you know which cable diameter is inside of the cable, that's most important. Cables from good brands, and like the original cables you get with your modern phones, they're all very good. It's especially the Chinese aftermarket brand which can be a problem. But I'll talk about that a bit in the end of the video. So what if you don't have quick charge or whatever other different way of charging your phone faster? How do you get the most amps out of your phones? Or I guess I should say into your phones. So as I said, I had a Transmart charger. And there's different brands like Aukey and Anker and others manufacturers that are coming out now, which say they have special techniques like this voltage IQ. And basically what it says is the texture device delivers the fastest charging speed, maximize compatibility, meet your different device various charging needs. Right. Basically there's a chip in here, and it detects what kind of phone is connected. Either it's an iPhone, or it's a Samsung, or it's an HTC, or a different charging chip manufacturer, and it tries to match the chip type to the fastest charging type. So an iPhone will charge at 1.5 amps, and your iPad will charge at 2.4, and your Samsung will also charge at 1.5 or 2. It won't raise the voltage because that's dangerous, but it'll give you the amperage in the right way, basically. So you don't need modified cables anymore, stuff like that. There's now a chip in the charger itself, which tries to recognize that and give you the fastest speeds. Okay, more about that in a bit, because that's an interesting feature. Lastly, what is the future? Well, I can't really say. Quick charge is gaining ground, and that's good, but it's a proprietary technology. You have to buy a license from Qualcomm. You have to integrate it in your phone. I'm not sure that's a viable solution in the long term. Another thing that's come out recently is USB 3.1 Gen 2 or Gen 1, but Gen 1 is basically 3.0 anyway. Stupid manufacturers made a really confusing mess out of it. Anytime I mention 3.1, I'm talking about Gen 2. Anyway, they also released a new type of plug with that. It's the Type C plug, and the Type C plug is slated to replace the micro USB plug. And it has several advantages. A, it's reversible, so no more trying to plug your phone in 50 times until you get it right. And B, it can carry a lot higher charge. Now, devices which support quick charge also work over USB-C, so that's no problem. But the USB-C standard itself also provides for higher power. Actually, in the latest charging standards, power delivery standards for USB, USB-C is rated to allow 100 watts of power delivery. Of course, that's an insane amount for your phone, but your laptop or Ultrabook or whatever of the sort, or some other device, could benefit from that. And if you could have a charger or a port which supports 5 watts, 10 watts, 20 watts, 50 watts, and 100 watts, all from the same charger, using different voltages and whatever, that would be a great universal solution. And USB-C with version 3.1 is looking like it's going to be that. So I'm hoping that phone manufacturers and other, basically phone board charging chip and SoC manufacturers will look at USB-C and go like, yeah, here's a standard which can do it all. Let's standardize these high-speed charging modes. So I don't know if it's going to happen. Currently, all the manufacturers are using Qualcomm chips. So as long as we're doing that, we'll probably be stuck with Quick Charge. And Quick Charge itself is okay. Especially 3.0 is very nice. But when other manufacturers, and mostly those change every few years, because a few years back we all had NVIDIA, and a few years before that we all had Texas Instrument chips, and now we have all Qualcomm, but who knows what we'll have in 2, 3, maybe 5 years. Yeah, I'm hoping they'll embrace these generic standards, and that will have a quick charging over USB-C, USB 3.1, Gen 2, as a standard. And we can just buy one charger. We can charge our phone, we can charge our power bank, we can charge our laptop, and it's all using the same plug and the same charger, and it all magically works. Well, I hope that explained it a bit, and you now know a bit more about charging and phones and cables and quick charge and stuff like that. I will be doing more tests in the future, basically to determine what is the ultimate Android phone charger, which one does it all in all phones at maximum speed, doesn't even exist, and basically do the specifications on these chargers actually meet what it's going to deliver. Because I wonder about that. Does it get hot? Will it explode? Should you get Chinese cables or not? Does it matter if your cable is 1 meter, 2 meters, 3 meters? I'm going to test all of that. And I'm going to show you guys. So hopefully that's interesting to you. And if you have any comments or questions, please let me know. And I'll try to respond to that. And I hope to see you back in the next video. Thanks a lot.